Hello everyone, welcome to Coders Camp. Hope you're all doing great. And today we are going to cover advantage shuffle. So the input given here is a two integer array A and B, and we have to return any permutation of A that maximize its advantage with respect to B. So what is the advantage of A? Advantage of A with respect to B is that the number of indices I for which A of I is greater than B of I. So let's understand this problem with an example. Here is a given example arrays A and B. So let's start checking from the zeroth index. So the zeroth index of A is 2 and zeroth index of B is 1. So obviously A's value is greater than 1. So the first index is having an advantage. Moving on to our next index, the value is 7 and the value at B is 10, which is actually less than 10, which is not having an advantage. Moving on to our third index, 11 is greater than 4, so this is an advantage thing, and last index 15 is greater than 11, which is again an advantage. So now this position is not giving us advantage because the value at A is less than value at B. So what can we do, or which values can we swap to make it work or have advantage in all the indexes? So let's shuffle the values 7 and 11. So the array becomes 2, 11, 7 and 15. So if you check the values now with B, 1, 10, 4 and 11, all the values in A are greater than all the values in B. So this is one of the permutation of array A that is completely having advantage over the array B. So this is going to be one of the outputs we can return. So how are we going to approach this problem? So here the idea is not to increase the advantage of all the elements but decrease the loss. So how are we going to do it? We're going to sort the array A from ascending order. So 2, 7, 11, 15, which is actually already sorted. So and B in descending order. So the values become 11, 10, 4 and 1. Now the idea is to map the higher value in array B with higher value in array A so that we can minimize the overall loss of given array. So now if we cannot map these values, that is if you consider the value at B, it is 11, and if you put the value correspondingly at the index 0 as 15, you will get advantage. The same way mapping the next greater value with the next greater value in the array A. By doing so, we will sort the array or permute the array A in the format that it gives maximum advantage. If suppose if the greater value is not greater than the value at array B, then in that case map that with the slower value, because we can use this maximum value in further or future elements to maximize our advantage. If we know we cannot win it, then put the smallest value to that and move on to check whether we can achieve advantage by fixing the maximum value for the second largest value. So we are going to do this with the help of two pointers. So first let's sort our array A and have our two pointers slow and fast. Slow points as the lowest or smallest element, and fast points at the higher value in the given array A. So now we are going to get the help of priority queue to store the values of B. Why priority queue? Because we also need the index of the given element. So to store index as well as in descending order, we get the help of priority queue. So our priority queue will save the elements in such a way that it sorts the element based on the value. So now the greater value in array B is 11. It is of at the index 3. So 3, 11 will be the first value entered into our priority queue. So the next greater element is 10, which is at the index 1. So the next value will be at 1, 10. And the next value goes like 2, 4 and finally enters 0, 1. So now we saved our array B with its index in our priority queue. Now it's time to check the values and construct our permuted array. So let's say our result array is of name result and has length of the size of array A. So now let's start comparing the first value in B array with the largest value in array A. So the first value we are going to compare is 11, which is at index 3. So we are now going to compare the value with the fast pointer because that is the maximum value in the given array A. So now if you compare 11 and 15, 11 is actually greater. So if you map 15 for 11, it is going to be an advantage. So now our 11 is at index 3. So in our result array, 15 is going to get the index 3. So now updating my array with 15 at index 3, moving on to my next value 10, which is at index 1. So now we are going to compare this value with the second largest value. So once we have used 15, our fast pointer moves to 11. So now we are comparing 10 with 11. So 11 is actually a greater value than 10. So it is an advantage. So 11 gets the place of index 1. So now I'm going to update 11 at the index 1. If suppose my 11 is not greater value than the value at B, we are going to assign the slower value because we know we cannot win with the faster value in this index. So we assign a slower value and move on to our next greater value to check whether it is a win situation by assigning the larger value to that number. Hope you're getting it. So let's move on to the next number, which is 4 at index 2. We are going to compare 4 with the next largest value. So once 11 is assigned, we are moving our fast pointer to 7, which is actually greater than 4. So now 7 gets the place of index 2. So I'm going to put 7 at index 2. Finally, moving my fast pointer to my first value 2 and comparing that with 1 in my priority queue, that is the last number at index 0, which is actually greater than 1. So if you assign 2 to correspondingly 1 at that position 0, it is going to win again. That is, it is going to be an advantage. So I'm finally updating 2 at the index 0. So this is my result array, which actually gives advantage over all the elements in my array B. So we are going to return it. Before getting into code, this actually works in big O of n log n, where log n time is used to save the elements and iterate the elements from the priority queue, and n is going to iterate our array A and B. So let's go to code now. Let me first initialize my result array. And sort my array A. Let us initialize our priority queue to store our index of array B and the values in descending order. So we wrote the comparator to sort the array in descending order based on the value in the given, based on the first index of the value we store in the priority queue. So now we are going to iterate our array B and store the value and index in our heap. Now we have put our index and array B's value to our heap, that is our priority queue. I'm gonna declare my two pointers. Slow starts at the 0th index of my array A and fast pointer is pointing at the last index of my array A. Because we sorted, it is gonna point at the higher value. So now I'm gonna iterate till my heap, that is queue, is empty. and take the value at the Q and assign the result array with values. That is, we are going to compare the value at our Q is greater than or equal to the value at the fast pointer. So if it is greater than, then if the value at B is greater, so we cannot win that situation. So we are going to assign the value at slow pointer. If not, we are going to assign the value at fast pointer and move the pointers accordingly. So yes, now we have computed our values in result array, and let's return result and run. So yes, let's submit. Yes, the solution is accepted. And thanks for watching the video. If you like the video, hit like and subscribe. Thank you.